We discussed A-level mathematics paper 1, pure mathematics 1 in October or November of year 2020. Question 1. We need to find the set of values of m for which the line with equation y equals mx minus 3 do not intersect the curve with the equation y equals 2x squared plus 5. So when they do not meet, there is no point of intersection. First, we assume that they intersect. We equate these two and write down 2x squared plus 5 equals mx minus 3. This is a quadratic equation, and we rearrange to write it in the standard form of ax squared plus bx plus c equals 0. So we move the right side to the left, and we have 2x squared minus mx plus 5 plus 3 equals 0. Then we have 2x squared minus mx plus 8 equals 0. Now this quadratic has three possible solutions. Either this quadratic has no real solution, one solution, or two solutions. Since the line do not intersect the curve, the discriminant b squared minus 4ac must be less than 0. For no point of intersection, the quadratic equation has no solution. The discriminant must be negative. From this equation, we see that a is 2, b is negative 1, and c is 8. b squared minus 4ac becomes negative m squared minus 4a is 2, c is 8, and this is less than 0, so that m squared minus 64 is less than 0. M squared minus 64 is a difference of squares. We have m minus 8, m plus 8 less than 0. The zeros for this part is negative 8 or 8. Now to solve the inequality m minus 8, m plus 8 less than 0, we can always use a sign diagram. We have two zeros for the left side of the inequality, which is negative 8 and 8. So for m minus 8, m minus 8 is positive for m greater than 8. So it has a positive sign here and negative elsewhere. So we say that m minus 8 is positive, m is greater than 8. This is the only interval. And for m plus 8, m plus 8 is positive when m is greater than negative 8. So these are the two positive intervals, and the last one is negative. We want to find the product of m plus 8 and m minus 8. We find the product of sign. This is a positive, positive, negative is a negative, and the last one is positive. And we want to solve for less than 0, negative sign. So m here must be in between negative 8 and 8. That will give you the set of values of m in which the line does not intersect the curve. For question 2, the equation of a curve is given such that dy dx is the reciprocal of x minus 3 squared plus x. The curve passes through the point with coordinates 2 and 7. We need to find the equation of the curve, meaning that we need to find y in terms of x. We can rewrite dy dx as x minus 3 to the negative 2 plus x. And then to find y, we just integrate dy dx with respect x. Upon integration, we have x minus 3 to the negative 1 over negative 1 plus 1 over 2x squared plus c. This is negative 1 over x minus 3. And then we need to find the constant of integration, which is c. To find the constant of integration from the points 2 and 7, we substitute x equals 2 and y equals 7 into y equals negative 1 over x minus 3 plus 1 over 2x squared plus c to find the constant of integration. Replace x with 2, we have 1 over 2 minus 3 plus 1 over 2, that is 2 squared, plus c, and y is 7. 2 minus 3 is negative 1, then half of 4 is 2, and the reciprocal of negative 1, 2 negative will give us a positive, and over here we see that c is 4. Then the equation that we need to find is negative 1 over x minus 3 plus 1 over 2x squared plus 4.